Good morning. We will start with the new lesson, Quadratic Equations, Session 1. We completed in our previous session pair of linear equations in two variables. So what is a quadratic equation? An equation of the form ax square plus bx plus c is equal to 0 is called a quadratic equation in variable x, where a, b, c are real numbers and a not equal to 0. In linear equation, what we saw was equation was in the form of x and y variable, where the standard form was ax plus by plus c is equal to 0, where two variables were involved in a given equation. Here, an equation in the form of a degree of square, a degree of 1 and a degree of 0, that is constant, in that form it is called as a quadratic equation. We all have studied in the first chapter what we dealt with polynomials. We understood about a quadratic polynomial, right? Yes. So similarly, a quadratic equation is always equated to 0. So these are few examples of quadratic equation what I have written. That means a quadratic equation must have a degree of square, which is compulsory. If x is there or x is not there, that doesn't matter, but it should always have an ax square term where b can be equal to 0 or not equal to 0. That will also do. That is, for example, a quadratic equation is further bifurcated in terms of pure quadratic equation and unaffected quadratic equation. Now what is this? Pure quadratic equation is an equation which is of the form ax square plus c is equal to 0. That means the variable x term does not exist. It is of the form 2a square minus 18 is equal to 0. We will get two solutions for this, right? Since it is a quadratic. Or x square minus 9 is equal to 0. Unaffected quadratic equation, when we talk about, it is of the form ax square plus bx plus c is equal to 0. Now in this chapter, we do not bifurcate the given quadratic equation in terms of pure and unaffected, but just for your information, you should know that quadratic equation can also be further classified into pure as well as unaffected. We just learn about quadratic equation and how to find the solutions in different methods to a given quadratic equation. So this is the basic introduction of the chapter. So you can copy this down and we'll quickly go to the first exercise. So we'll begin with the first exercise. Check whether the following are quadratic equations. Now just by looking at this we cannot say, because they have given in terms of binomial, squaring, subtracting, adding is there. Let us simplify that and check whether it is a quadratic equation or not. First one, x plus 1 whole square is equal to 2 of x minus 3. X plus 1 whole square is equal to 2 of x minus 3. So looking at this, you cannot tell whether it is a quadratic or not. Let us solve it. A plus b whole square, a square plus b square plus 2ab. This is equal to 2x minus 6. X square plus 1 plus 2x minus 2x and plus 6. Plus 2x minus 2x will get cancelled. 1 plus 6 is 7 is equal to 0. So this is x square plus 7 is equal to 0. Now this is a unaffected. That means yes, it is a quadratic equation. I'm sorry, this is pure quadratic equation. Unaffected, what will be there? X term also will be there. So in pure, x square term will be there, no x term and a constant. But here you need not bifurcate whether it is a pure or unaffected. Just write it is a quadratic or not, and one extra thing, why it is quadratic. The given, it is of the form, we can just conclude, it is of the form ax square, I will write plus c is equal to 0, where b is not there, that is okay. Therefore, what they have given, whether the following are quadratic equation. Therefore, it is a quadratic equation. It is a quadratic equation. Let's check with the second one. X square minus 2x is equal to minus 2 of 3 minus x. Keeping this x square minus 2x as it is equal to minus 2 into 3 is minus 6, minus into minus plus 2x. Shift to this side. X square minus 2x, again minus 2x, this plus 2x this side, plus 6 is equal to 0. X square minus 4x plus 6 is equal to 0. X square minus 2x minus 2 of 3 minus x. Okay. Is this of the form ax square plus ax square plus bx plus c is equal to 0? Yes. It is of the form, it is of the form ax square plus bx plus c is equal to 0. Therefore, it is a quadratic equation. And just write the shortcut, quadratic equation, right? So let's quickly begin with the next one and check here. Third one. X minus 2, x plus 1 is equal to x minus 1 and x plus 3. X minus 2 of x plus 1 is equal to x minus 1 of x plus 3. Let's do the binomial by binomial multiplication here. So this is x square plus x minus 2x minus 2 is equal to x square plus 3x minus x minus 3. So x square x minus 2x is minus x minus 2 is equal to x square plus 2x minus 3. If I transpose everything this side, x square minus x minus 2 minus x square minus 2x plus 3 is equal to 0. X square and x square cancel. When x square term only is not there, that means it is not a quadratic equation. Okay, check with minus x minus 2x minus 3x plus 3 minus 2x plus 1. It is minus 3x plus 1 minus 3x plus 1 is equal to 0. It is not of the form ax square plus bx plus c is equal to 0. Therefore, it is not a quadratic equation. Yes? So like that only we have to solve the remaining ones. Remaining ones will solve them. Okay, I have marked 2 homework sums in this one. That is, fourth one I have first being, fourth one is marked for homework, fifth one is marked for homework. 2 I have given for homework. I'll start with sixth one. So sixth one is x square plus 3x plus 1 is equal to x minus 2 whole square. X square plus 3x plus 1 is equal to x minus 2 whole square. Now children, just don't look at this term and tell it is a quadratic, so it is a quadratic equation. You need to first solve and then verify. Let's solve this. X square plus 3x plus 1 is equal to a minus b whole square. A square plus b square minus 2ab. Okay. Of course, x square and x square will get cancelled here only if you want. I'll write anyhow if you want. We will write it here. X square plus 3x plus 1 minus x square minus 4 plus 4x is equal to 0. These two will become minus and this will become plus. X square cancel. 3x plus 4x, 7x, minus 4 plus 3 is minus 3 is equal to 0. It is not of the form, it is not, x square term is not there. That means it is a linear equation but not a quadratic equation. It is not of the form ax square plus bx plus c is equal to 0. Therefore, it is not a quadratic equation. You are not supposed to write QE. You are supposed to write completely quadratic equation. Okay. Seventh one. X plus 2 whole cube is equal to 2x of x square minus 1. Let me simplify this. It is a plus b whole cube, which is a cube plus b cube plus 3ab, 3 into x into 2 of a plus b. Do you remember this formula? A plus b whole cube. A cube plus b cube plus 3ab dot represents into of a plus b is equal to 2x cube minus 2x. I multiplied with this. Here x cube plus 8, 3 2s are 6x. 6x into x will give you 6x square. 3 2s are 6x into 2, 6 2s are 12x minus 2x cube minus plus 2x. Looking at this, do you think, see, we get one x cube term. It has x cube, x square, x and a constant. It is not a quadratic equation because a quadratic equation has to be in a x square, x and a constant form. But still you have to simplify. Minus x cube, 6x square, only one x square term is there, plus x cube and x cube we did. So then 6x square, any x term is there, 12x and 2x, 14x plus 8 is equal to 0. So what will you write? It is not of the form ax cube plus, ax cube I am writing, ax square plus bx plus c is equal to 0. Therefore, it is not a quadratic equation, right? And the last one, 8th one. Eighth one is again similar. X cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube. X cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube. So x cube as it is minus 4x square minus x plus 1 is equal to a cube minus b cube. It is a, here it was a plus b, there it is a minus b. A cube minus b cube minus 3 into a into b of a minus b. X cube minus 4x square minus x plus 1 is equal to x cube minus 8. 3 2s are 6x, 6x into x minus 6x square minus plus 3 2s are 6x into 2, 12x. Same what you get here, everything is in minus. Okay, we'll do it here only. Anyways, I'll take it. X cube minus 4x square minus x plus 1 minus x cube plus 8 plus 6x square minus 12x. X cube and x cube is getting cancelled. That means we retain the x square term. Minus 4x square plus 6x square is 2x square. Then do we have x term? Minus x minus 12x minus 13x, 8 plus 1 is 9 is equal to 0. What will be the conclusion? It is of the form ax square plus bx plus c is equal equal to 0. Therefore, it is a quadratic equation. Now, did you understand how to identify a quadratic equation? It has to be in the form of ax square plus bx plus c is equal to 0, or ax square plus c is equal to 0. Only then it is a quadratic equation. Okay. We'll quickly start with the next one. Next one is very simple, where they have asked us to frame the algebraic equation, that is a quadratic equation only in terms of x, but we did not find the solution for it. So here in this exercise, we are only supposed to frame the equation. Framing equation is very important, children. You might have understood now. Until you frame the equation correctly, you cannot get the right answer. So, represent the situation in the following in the form of quadratic equation. Read the question. Represent the situations in the form of quadratic equation. That's all. Frame the equation and leave it. Second main. First one. The area of a rectangular plot is 528 meters square. The length of a plot in meters is 1 more than twice its breadth. We need to find the length and breadth of a plot. Of course, yes, but not here. It's only framing equation. The length of the plot is 1 more than twice its breadth. Let the breadth of a rectangular plot B is equal to x meter according to them. Okay. So what they have given by data. What is length? The length of a rectangular plot is 1 more than twice its breadth. Correct? The length of a rectangular plot in meters is 1 more than twice its breadth. So length is written as 1 more than twice its breadth is 2x. Further, area of a plot is given. How much? 528 meter square. How do we write area? So length into breadth is equal to 528, right? Length is what? 1 plus 2x. What is breadth? Breadth is x is equal to 528. So x plus 2x square is equal to 528. Yes, but children, after you write this, you need to arrange this in the form of ax square plus bx plus c is equal to 0. So first will come ax square, that is 2x square plus x minus 528 is equal to 0. That's all. We need to only frame the equation here. Next exercise, we need to frame the equation as well find the solution, that is length and breadth respectively. I think I'll do it here only, the next one. Second one, the product of two consecutive positive integers is 306. We need to find the integers. Everywhere they have given we need to find the age. That means not here, later. We have to frame this. Product of two consecutive integers is 306. Let the two consecutive integers be x plus 1. By data, what they have given, product is 306. X of x plus 1 is equal to 306. X square plus x is equal to 306. How do you write? X square plus x minus 306 is equal to 0 is the second equation what you have to frame. So, very clear how to frame the quadratic equation. Okay, we'll go with the third one. Rohan's mother is 26 years older than him. Third one. Rohan's mother is 26 years older than him. The product of their ages in years, 3 years from now, will be 360. We would like, excuse me, we would like to find Rohan's present age. Not now, only algebraically we have to frame it. So Rohan's mother is 26 years older than him. So how do we frame this third one? Let whose age? Rohan's age. Rohan's age be. Now children, can you frame this here, this equation in linear also? Just check. But if in case you have to frame the linear equation, they should give you two different conditions, right? You need to be very careful. Sometimes, now we are solving quadratic. So you feel that, okay, this is all into quadratic. Tomorrow in exam, when these sums are given, you should know whether this is a quadratic or whether this is linear. How do we come to know? We'll understand that. By the end of this chapter, you will be able to identify which sums can be solved only by quadratic, which sum can be solved only by linear, and which sums can be solved both by quadratic and linear. Okay. Let Rohan's age be x years. Rohan's mother's age B. She is 26 years older than him. X plus 26 years. Okay. Now the next is 3 years later. 3 years from now. 3 years from now. So what will be Rohan's age 3 years from now? Rohan's age will be x plus 3 years. And Rohan's mother's age will be x plus 26 plus 3, which is nothing but x plus 29 years. Okay. Let's see the question further again. The product of their ages will be 360. 3 years from now, the product of their ages will be 360 by data. So Rohan's age, that is x plus 3 into Rohan's mother's age, x plus 29 will be how much? 360 years. Okay. So let's frame. This is not an equation. We need to frame it. So let's do that. X into x. X square, x into 29 plus 29x plus 3x, 29 3s are 9 3s are 27 6, so this is 87 is equal to 360. Don't write degrees, I have written degrees by mistake. Okay. X square 29 plus 3 32, 32x plus 87 minus 360 is equal to 0. X square plus 32x minus 360 minus 87, you will get 273 is equal to 0 is your equation. So this is how you only frame the equation. How to finally find it? That is by factorization, splitting middle term. We'll be doing that in our next exercise. X square plus 32x minus 273 is equal to 0 is the equation. The last sum, if you remember children, we had discussed this type of a sum in linear equation, but it was a bit different from this, but more or less the similar one. Very important sum, the next one what I am solving. So read the question. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. So let us assume that fourth one, right? Let the uniform speed of the train be x kilometer per hour. Children, if you remember, there was a question which was there in the previous chapter. I don't remember exactly, I will just check, but where time was to be written, and time also I have written in terms of kilometer per hour. So please do that necessary changes. I'll just check and I'll message you that. Where speed is in kilometer per hour and y was taken in terms of time, that also I have written in kilometers per hour. That should be in terms of hours. Okay, come to this sum. Let the uniform speed be x kilometer per hour. Okay. What's the distance given? Distance is 480 kilometer. So, anything else they have given? We know that. We will write off here and keep. What do we know? Speed is equal to distance by time. Here we know something about speed and distance, but time is to be found out. So we write this in terms of time is equal to distance by speed. In this manner we will consider this. Okay, read the question further again. If the speed has been 8 km per hour less, if the speed is decreased by 8 km per hour, what will be the equation? Speed is what? X minus 8 km per hour. Okay, this is the speed. Now keep it as it is. If the speed had been 8 km per hour less, it would have taken 3 hours more to cover the same distance. That means by data, here the equation bringing is very important. If the speed had been with respect to what distance? 480, no? Yeah, 480. If the speed of the what distance by time, distance by speed when we are saying, if the speed was reduced by 8 km, then the time taken to travel the journey, what journey? 480 upon x, it would have been taken, where it is? It would have been taken 3 hours more. Did you understand the equation here? If the speed was reduced by 8 km, that is what I have written here, the time taken to travel what? If I am taking some time to travel this journey, if I reduce the speed, the time taken would be this time plus extra 3 hours. This is the equation what you should know to write. Now it is simple, frame it, shift this x term here. So 480 upon x minus 8 minus 480 upon x is equal to 3. I'll solve this side. So LCM would be, see, in this case, under such monomial binomial term, LCM would be product of these terms. So LCM is x of x minus 8. We have x minus 8, multiply this by x. We have x here, multiply this by x minus 8. Write it. 480 x minus 480 x minus it is plus. So 1 second. Okay, 480x minus this. What we will do, children, here is, since it will become a bit lengthy, I mean, you have to again multiply 480 into 8. So what we will do here is, before we take the LCM, okay, before we take the LCM, I'll take off 480 common. If I take 480 common, what will remain? 1 upon x minus 8 minus 1 upon x is equal to 3. I think this sounds much better. So 1 upon x minus 8 minus 1 upon x is equal to 3 upon 480. I just brought this 480 down. Now we will do our usual LCM process. x upon x minus 8. So this multiplied by x, this multiplied by x minus 8. So this will be x minus into x is minus x, minus into minus plus 8 is equal to 3 ones are 3, 3 ones are 3, 3 6 are 18, 0. Where x and x will get cancelled, only this will remain. Let's cross multiply with this. X into x square minus 8x is equal to 16 8s are 128, 0. So x square minus 8x minus 1280 is equal to 0 is the equation what you will get it. So this is the quadratic equation what you have to solve. So then we complete this exercise. You can also do that, but I thought let us make it simple by just taking common and doing it, right? So we will be dealing with such type of many verbal sums, very important one. So with this we complete this. Next exercise, we will be understanding about solution to the quadratic equation by factorization method. We already know this method since we have already done this in polynomials chapter. So with this we complete today's class. So in next session we understand a solution to the quadratic equation, that is by factorization method. Thank you.